Hey there folks, welcome to a super exciting video. Some of the previous videos might have been theoretical. You would have gotten a framework, some best practices. This one is going to be a more practical version. We're going to have a problem statement. We're going to work through this problem statement. We're going to build a pipeline. It's going to be really exciting, and we'll be discussing trade-offs, and you'll understand better on how a lot of production level work takes place. This is of course going to be a simulated environment. What I'm going to show you is a tool that we have internally developed. It's called as the ML Design Studio. It is specifically meant for improving your design skills from a machine learning perspective, right? You want to build and design better pipelines, then this is a small tool that we have built, which we internally use as well. And in fact, it's amazing from a training perspective, for interview preparation, for just brainstorming, honing on your skills, etc. Some sort of speciality and peculiarities of this tool you will see that as the tool is being used, but very briefly, it has basically a bunch of like pre-built units in here, and you can sort of have it's a drag and drop editor. You can enter some text and drop in some connections between this text, note down your assumptions and notes and stuff like that. And also what's very special is something which we are working on is having a better automated evaluation of your flowchart and of your diagrams and pipelines, so that you can get instantaneous feedback on where you are lacking. There's a lot of interesting stuff in here, so I don't want to spend too much time on theory. Let us get right into it, right? The problem that we're going to attack today is one which is very practical. It's an unsolved problem. In those of you who are in the financial analytics space and who are doing AI in that specific space would be aware of the challenges of this problem. So the problem is that let's say that you're working at I don't know, so maybe you're working at one of these NBFCs, and you are now given a task to retrieve data from financial statements, right? And the folks higher up have come and told you that hey, looks like AI is able to do a lot of stuff, and what we'd like to do is build an internal system so that we can retrieve data from financial statements, right? So it's a broad blanket statement that the business folks have come and given to you, right? You know how to go about designing the system. Okay, now up top itself, I'm sure there's a lot of open questions that would have come to your mind. Anytime you're given a problem of this sort, right, my recommendation to you is first, like I'll link in the theoretical video on which we talked about the frameworks and how to work through any problem. We're going to work through the problem using those same set of steps, and I hope it's going to reinforce the process and framework for you. Okay, so if you're not seeing that video, we'll link it in the description somewhere at the top. Hopefully it comes up and you can go and view that video to ensure you're solid on the framework part of it and all the practical tips and tricks that we have shared basis all the experience that our team and several others in fact have, right? Now coming to the problem, right? Retrieve data from financial statements. Now obviously here all of these should never be done in isolation. You should always have a conversation with the person who's giving you the problem to understand the requirements of the problem better, right? One of the things that we mentioned earlier is the first thing that, the moment somebody sees something of this sort, a question, a very junior level or an inexperienced approach to this is to look at it from a model first front by saying, oh, I can use this model and that model and this is how we'll do it, right? That's a very incorrect way of going about it. You should not look at what's the best model to do this. There is a process before which you do this. There's a process before which you can actually get to that step, and that process is relatively long. So we're going to work through that, right? So we'll start out with, first of all, understanding the statement better, and you get on call with this person and have a conversation. So I'll because obviously we don't have that person here, and I'll kind of role play across both. So let's say that you ask the person, hey, I want to understand the problem slightly better, right? You're saying retrieve data and you're saying financial statements. Can you specifically tell me what are the kinds of financial statements that you see, right? So we're going to write down some of these assumptions here. So they'll be set in stone, and the evaluation that will take place will be keeping these assumptions in mind. So one could be, so I'll write, say, hey, financial statements, right? So this other person, so he says, hey, you know what, PDFs, we're looking at largely scanned PDFs. Sorry for the impersonation, guys. So they're saying we're going to look at these scanned PDFs, right? We say, all right, scanned PDFs, right? You say, is there anything else that you want to look at? He says, some of these are scanned PDFs, but you know, some of them, they could be even be like digitally created exports of Excel, but they still be in PDF format. We want to address PDFs right now. Okay, cool. So you say scan PDFs and you say digital PDFs. All right, great. So you know what kind of stuff that you're working with, what's the input that you're going to receive. So digital PDFs, right. Okay, cool. So that's one assumption, right? Now the second bit is you say retrieve data. What is the, so you go back to this guy and say, hey, can you tell me what is the exact kind of data that you want retrieved, right? Because a financial statement is very broad. It's pretty broad, and what exactly you're looking for from that can be dependent on what is the end goal. Are you looking at anomaly detection? Are you looking at some advanced analytics, forecasting, right? Or you're just trying to do like some basic reconciliation. So depending on the end goal, the kind of data that needs to be created for that can be very different, right? So you go to this guy and ask this question, and then he comes back with an answer saying, hey, you know what, nothing too advanced right now. All we're going to do is I just want you to pick out the balance sheet, the P&L and cash flow, that just structured data for these three entities. And then, you know, our analytics team can then later on figure out what they want to do with this. Okay. So saying, okay, great. All right. So when we say retrieved data, which is basically the output that you're looking for, is going to be structured. So that's one thing, structured, and that will be the balance sheet, P&L and cash flow, right? Okay, so at least you know what you're going to get as an input, what is the output that you have to produce. Okay, at this point in time in a real exercise, I would actually take a look at the data itself to understand the nuances of data, right? So when you understand the problem, the inputs, the outputs, what is the expectation out of you, you should also understand the data itself and the peculiarities of that data much before you go and build the pipeline, right? So in this instance, so maybe let's just, I've just for the sake of a completeness, right? Let's say financial statements, maybe we do, let's say India, and I can say pick out some images, for example, and we have a bunch of financial statements here. So you can see that, you know, some of these statements, so this could be one kind of statement which is there, and this is doesn't have any tables. So that's one observation I can see over here. And there are totals in here. It looks like there's some sort of a hierarchical structure where parent and child items are structured one inside the other, right? So there's an interesting relationship going on here. So there's a total is the sum of all the other rows. So it's not even though structurally it's a scanned PDF, it's not just a simple scanned PDF, correct? There is where every line is isolated, right? It's not just pure text where every line is isolated. There is some mathematics going on in between these lines. There's a relationship in there. And there are other relationships also in a balance sheet, right? The balance sheet should tally and etc. etc. I am not an expert in the field itself in finance, but you know, because you know I run a company here, and then we are exposed to the accounting team, and there are certain things that come out because every year you have to do your filings, right? So basis my limited understanding, I'm going by that, but you have the other person at the end to have these clarifications to understand what is the kind of data that you're seeing, right? So here is one data, a few quick observations we had. Another one here, you can see that it's a table format, so it's probably easier to parse. Guesswork again, I'm not very sure. The initial ideas here going around. There are some scheduled base numbers mentioned here, and in addition to previous year and next year stuff. I see that there is something called as consolidated here, which means that I mean my knowledge also tells me that apart from consolidated, you also have what is it called? Some sort of entity level or an I think I don't remember what it's called. I remember seeing it in some of these stock screeners and so on when they give the financials of companies, right? So different kinds of statements as well. So again, there's an open question: what are you going to address? Is the format of that slightly different, right? So again, bunch of other statements here. Varun Beverages out here. I'm hoping this data is all public data because we are finding it on the internet through random search and images. Quick disclaimers: I don't own any of this data, so if this is coming out on any platform, this video, then the owners of this data, the owners of the data, we are just happening to show this right here, right? So that's a little bit on the format, and this is what we are seeing, right? So there can be quite some wide variety of formats that are present. You can see there are a number of columns are not static. You have this. Yeah, there I think there's some analytics that's going on here, some additional preparation. So every company might be using different sorts of software to build this, and the kind of formats that they might be getting might be slightly different company to company. Even if it's within the same software, I think that my understanding is there are certain standards by which you do reporting, and basis those standards, there is some flexibility on how you mention certain things, right? So you don't need to like word for word mention certain things in a certain way. So which means that I cannot just always remember that a specific line item is a specific line item. So we can't necessarily add that into memory. There has to be like semantically similar meaning in that, right? So I can't directly always say that under revenue I will find maybe cost of goods sold or distribution expenses mentioned here, etc., etc. It might be something a different company might mention it slightly differently, right? So stuff like that. So obviously this is the complexity that is there in the data. And to add to this, you're saying that I'm looking at digitally prepared statements, and I'm also looking at scanned copies, right? This could be like a scanned copy, which is sent. The other open question that's coming to my mind is, especially if you look at a country like India, I do know that you can file in different languages, right? So we are going to make the assumption that the statements are all in English for the sake of simplicity, right? If not, this video is going to go on forever if I don't limit the scope of it, right? In reality, the discussion could be much deeper, right? So we're going to say the scope of language is we're going to look at only English language statements. Okay, so these are the assumptions. Now so a little bit more on the data, right? And this is a great time. So once you have an understanding of the input, the output, you've had a look at some of the data, hopefully you have a few samples at least to look at, right, when you're starting out the problem. This is a very good time for us to have a conversation on what kind of, so ideally, in a lot of scenarios, you need to have you might build a solution, but for you to evaluate that solution, you need to have the correct answer, right? Or at least a few samples of that correct answer, so you can calibrate and decide which direction I should go in, right? So I'm going to make some assumptions here that we are working with these financial statements. So clearly we just were able to pull up many on Google, right? So we're going to make some assumption that we will have lots of input statements of companies, and these would basically be publicly available, right? But it's also required. Now we are going to do a process where we are going to extract some specific data. So it would be very helpful if that specific data is we have the ground truth for that. Right now, obviously, if you're training a custom model or you want to go about it that way, I don't want to start any discussion on the pipeline yet, right? But just a teaser is that if you're training any custom model, you need a large amount of data, and for you to evaluate how much data you need to look at the fundamental capabilities of that model, and that's a whole data exercise in itself, right? But even in the framework video, when we talked about it, when you're building the version 1, the idea of what we're trying to do is, out of this entire exercise, is understand the requirements and build a version 1. And that version 1 is a baseline that goes from problem to solution, right? So when I look at it from that perspective, the aim here of the baseline is I get all the nuances of that pipeline sorted out so that I can take it to production, and every single team involved, multiple stakeholders are all on board. Further, from the baseline, the idea is speed and proving that this use case can be solved using this sort of a method, right? Or it's solvable using AI, or you are able to have some gain using AI. So which means when the aim is speed, you don't want to necessarily enter into a large data labeling exercise, right? If you have the budget and time for that, it's all perfectly fine. Even if so, I would recommend that for you to establish a baseline, you are got to do it fast. So if you have to do it fast, don't enter data labeling exercise. So the comment that I'm going to drop right now is going to be from that perspective. And the comment is that we will need, say, just from an evaluation set perspective, a test set perspective, right? I'll say we will need hand labeled outputs, say about 20 of them, right? This is just a random number for me to ensure there's reasonable robustness. Okay. For verification, I'll say probably and later fine tuning. So that is we'll explore. You might need more data, less data. Less is probably not, but if the existing solutions are already good, and you'll evaluate and figure that piece out, right? So this is what we need, right? So this is from a test set perspective. Some open ideas here from the evaluation perspective, right? Because when you're setting out here, you're looking at data from two lenses. One is, how do I know the correct answer and evaluate, and what kind of metrics do I want to use, right? So look at the data, look at the metrics, right? That's the step that we are on right now. I will say that if I don't have access to domain experts, we can use LLM as a judge for evaluating, and alternatively have human in the loop to examine the quality of the outputs. Okay. So hopefully that makes sense. We will have a lot of input statements of companies which are publicly available, but alternatively we will also need hand labeled outputs for verification and later fine tuning. We can use LLM as a judge for evaluation, and alternatively have human loop to examine the quality of outputs, right? So far what we have discussed is we have understood the input, we have understood the output, we have looked at the data, we have understood a little bit about the data, and we are forming a brief a roadmap on thinking about how we will evaluate the solution, right? And when we're saying, okay, I'm probably looking at using LLM as a judge, this would also be a good time for us to say what kind of metrics you're going to use to judge quality and things like that. But I don't want to get into that in that depth right now itself, right? But it would be also a good time if you were to state that out, then there's no harm, right? What I also want to bring to your attention at this point in time, right? So we looked at these couple of steps. When you are doing this in a live setting in production, when you're actually given a problem, right? This is how you will think through it. When you're doing it in an interview setting, this whole iteration and feedback might be a bit faster, because the interviewer per se would want to understand your decision making process, understand the trade-offs between every decision that you're taking. And you have to keep in mind that multiple possible designs can be correct, right? And just how you're thinking through those trade-offs is something that you have to bring out in this discussion. So from an interview perspective, it will be slightly different. I would not be making quick assumptions that I need 20 samples of data and things like that, right? But when I'm actually working on the problem, I would deal with it slightly differently, I would say, and I'm thinking out loud here. Right? I'm solving the problem with you guys. I'm thinking out loud. I don't have anything prepared for this problem as such. But full disclosure, we have worked on these sorts of problems for our clients in consultancy. Right? As part of the consultancy business, we work with clients in financial services. So the problem is not unfamiliar to me, but the specifics of the problem we will work out right now, because we are making some very specific kind of assumptions. Okay? Right. Now, the next bit is, if you look at the framework that we talked about, right? You have to now look at constraints, right? Don't go building in any solution without having understanding of constraints. So let's look at constraints, right? So the constraints that we need to know about in this whole solution, cost, latency, what kind of processing are you looking at? Is it I think latency will also answer that if you are looking at something real time. right? So the scaling, all of that will kind of come into the picture. So let's make some assumptions here, right? So you go and ask this guy, what are the constraints on this problem? What are we working with, right? And then he tells you, hey, you know what, from a cost perspective, by the way, I'm sorry if the guy's voice changed, right? So you say, from a cost perspective, let's say maybe I'm looking at under $1 per document. And then from a latency perspective, let's say I am looking at it with, maybe I'm okay with batch processing because the team that's going to be using this is not necessarily looking at it live, right? And if it's batch processing, that hopefully you get the answer in, let's say, less than 10 minutes, depending on load and how all of that is structured. And you probably also should, so the thing is, in an interview setting, you should have this conversation to bring out or make these assumptions on your bit, right? You need to, but explicitly always state the assumptions, because you're going to be building with those constraints. Those constraints are very critical, right? So I would probably say something like, okay, this sounds good, but the scale at a monthly level, what's the scale going to be? So something like, we would say that, all right, we're looking at something like, say, 1,000 documents per month, with each document maybe having 10 pages. Right, pretty decent start there. And because you're working in the financial domain, a very important question that should come to you from a responsible AI perspective is privacy, right? And more often than not, the answer to this is that you want to ensure that you're not using any external APIs. So I will make that privacy is going to be a very, very important and interesting constraint, and we'll see how to handle that, right? So you're going to say privacy is a constraint, so which means no external APIs, and we will look at maybe self-hosting or on-prem maybe models. Right. So what this also means is you're probably going to be looking at some open source models to work with. You'll start with looking at these open source models, what you can do with these open source models, etc., right? Right. The other bit that oftentimes comes if you've done a little bit of system design, software system design, machine learning system design is completely different, right? But there are some principles which are worth, especially from a production perspective, drawing from there. So something which has to come into the picture here is, how is concurrency handled? How is load balancing handled? Because these models will also be hosted on some sort of servers. So let's say you're using Azure or AWS, GCP, it doesn't matter what you're using. There'll be some sort of servers. You'll have to do some load testing. Basis that load testing, you will have to auto scale them for the specific, we have made some assumptions here that there's going to be 1,000 documents coming in per month. But there's nothing here mentioned about, are those 1,000 documents going to come together? Right? Or are they going to be spread out across the month? So how is the concurrency of it going to look like? Right? That's a very important bit as well. Okay. So on the concurrency bit, we can say that concurrency bit, we can say that, it becomes a very the whole discussion over here will become very production oriented if we have very stringent concurrency constraints. So therefore I probably would stay away from that right now, and I would say that we are largely doing batch processing, and we are okay to have maybe 2 or 3 documents sent at a time, right? So something of that sort, maybe limited number of documents, we can wait. Okay, that's the general idea, that we can wait for processing these documents, and you're not going to have any burst. That's the general idea. So there's no burst traffic coming in here, right? Okay, so we have I think outlined quite a few things on the constraints bit. One specific aspect that I think you should always have a discussion on when you're building these systems, right? So far I think we have a pretty complete picture on what we're looking at. What's the input, what's the output, what's the kind of data that we should be working with? What are the constraints looking like for the system? How, we've added things from responsible AI and production level constraints and stuff like that. The other bit that you should always have a conversation on is, and maybe I missed it out, apart from you looking at it from an machine learning and AI objective perspective, right? So you're probably going to state a metric here. You will say that, okay, I'm looking at I don't know. So you could say, if I'm an image perspective, you can look at some sort of metric, right? Or you want human level evaluation on whether it's correct or incorrect, right? If you're having human in the loop for actually evaluating rather than LLM as a judge. So you can figure out a metric here from an ML perspective. But you should also have the conversation on the business perspective. What is the aim? Right? So from a business perspective, having that goal in mind will allow you to ensure how you can eventually tune the system, right? And so I'll say that, let's say, for example, the business goal here is to, you are already working with these existing documents and you want to reduce the time to process these documents, right? Today, if these documents are to be processed with complete manual review, 1,000 documents would, let's say, for example, take a month. Now, you perhaps are now trying to see that, okay, this whole system is going to cost you X. You have to look at it from a business lens also, right? If not, your projects actually don't add value. So if running this entire ecosystem for these 1,000 documents in that month is going to cost you X, does it make sense to spend X and do it in 25% of the time? Or, if you spend, say, 4X and do it in 25% of the time, the remaining time that's saved for the team, what can they do with that time such that it is much, much faster, right? Because in the time spent, you're also paying them a salary or whatever compensation that kind of team is working with, and you have to kind of evaluate the cost of this pipeline and the impact of it in terms of time and whatever other business goals you're looking at. Is it worth the cost of the pipeline? And if yes, what kind of impact is it going to have? What kind of time is it going to free up for the rest of the people? What kind of maybe it doesn't free up time, right? That could not be a goal. So it depends on what you're looking at. Maybe it just makes a really tough task easier, and they doing manual review could be resulting in a lot of errors because you're manually going through it. An automated system maybe brings down the errors. That could be your goal, right? So it depends on what the goal is. I'm going to go with the goal that you're trying to reduce the time to process these documents. Okay. Right. Now I think we have, to a large extent, completed the whole requirements piece. This would now be a good time to start discussing how are we going to build this ecosystem, right? We're going to look at it I'll try to get in maybe one more extra iteration in, but the idea is first we build a baseline, right? The baseline is going to be something very, very simple, and we largely just get it into production, get it to work, right? That's the idea. Then once the baseline is built, just like how we discussed in the other frameworks video, once the baseline is built, we will then do a qualitative and quantitative analysis. I obviously will not be able to do that right now here because we don't have the live data or any of the answers, right? But it will give you some insights on where the system is going wrong, what you can do better, and we have certain levers to pull, which we also talked about in that video. So you can try to pull some of those levers, and again, keeping the interest of time in mind for this POC / baseline. You can see what are those levers you want to pull and how can you give maybe another subsequent iteration, right? So that's how we're going to approach it first for the baseline, right? Now there's a lot of pre-built modules here that you can start picking up to build this, right? So we're getting into the exciting part now when we are actually going to do the building blocks and build stuff, right? So first things first, what is coming to my mind is, because you're having, say, scanned PDFs in here. For digital PDFs, there are obviously pre-existing libraries, right? Where it probably does a decent job of trying to extract the tables from the libraries and stuff like that. But when you're looking at scanned PDFs, these scanned PDFs would require some form of OCR. Right? If I were to be dealing with a different format, say Excel, right? Because it's financial statements, a lot of them give it to you in Excel as well, and that's a very, very important format to address there, because there's formulas, linkages, and the kind of metadata that is available in an Excel sheet is huge, right? But obviously for this discussion, right? For this discussion, we want to limit the scope so you get an idea about the process, right? At every point in time, I'm going to make some assumptions right now. The question is, and we will not be able to discuss every single assumption and trade-off here, but you for sure need to have that discussion on understanding what are the trade-offs going to be like for going about it a certain way. Okay, so scan PDF. So initial idea is that I will probably need some form of OCR. Okay, so let's do that. So we will say that we are going to start out with some sort of input. So sorry, just a second. All right, you can search for stuff here. So you can search for input and things like that, and you can drag and drop. What I will be doing is I am looking at something very custom. So I'll be using these custom blocks, so it makes it a little bit easier, right? So I'm going to say the input is a scanned PDF, and this is roughly going to be approx 10 pages. Right, this is where I'm looking at it from, and I would look at it from two lenses. One is obviously I'm aware of all the constraints and everything else which will feed into the design. But when I'm designing this, I'm going to do it in maybe two iterations, where first I will look at it from a machine learning pipeline in isolation. So we will do that first, and we'll build the baseline with that in mind. Then we will add all the production level infra which is required around that. So we'll do that as a subsequent iteration, right? And then we will do a true iteration that now that end-to-end is done on saying how can we improve this pipeline, right? So input, we have the scanned PDF here as input. Now OCR pipelines, basis my understanding, you can do a little bit of research. OCR pipelines, they work on some of them. I mean, so they don't work on PDFs, right? They work on images, right? So that's one bit on these OCR pipelines. The other bit on these OCR pipelines is that prior to even actually getting to this OCR pipelines itself, right? This input data itself might require some form of normalization, because the moment I say scanned, what is coming to my mind is that, you know, when you scan them, there could be like some differences in contrast, right? So there could be a requirement of some form of normalization, right? Like some equalization in those images to make them a little bit more readable. If it's like a hand photographed image, it's going to be even worse. So there's some standardization and image processing that needs to be done to bring them to a normalized form, which is more readable and makes it easier for our pipelines, right? So most pipelines, from the input, there will be some form of pre-processing with some feature extraction engineering which is required to make them slightly better, right, and more suitable for your pipelines. So in this instance, what I would say is that I'll work with a lot of these custom blocks, so it's kind of easier. I will say that I'm going to need a PDF to PNG, because I know my OCR pipelines work on that. So this is largely for the input to the OCR model. Sorry. Yeah. Okay. Awesome. So these two now get connected. Great, awesome. The next bit is we just talked about some form of standardization, right? So we will do the standardization on the input side. So I will say I'm going to do some form of normalization, and the aim for this image normalization is that there could be, say, color or let's call it contrast. We have to do some form of equalization for these images. The other also interesting bit here is that when we went to some of this financial data, I have actually seen some larger, we saw it in largely a vertical format, right? And now because we have worked with our clients, and when you actually look at the data, you'll notice that some of the data is not necessarily in row format, they're in column, not in column format, they're in row format, which means the whole table is rotated because it needs that landscape view as opposed to a portrait view, right? So it would be interesting to also see how do you rotate, like detect and rotate if required. So that's going to be an interesting problem to look at. But the thought process that I'm coming down with, I mean, what's coming to my mind is if I get into that, I probably might need something separate, a model or a module or some library for me to do that sort of detection and figure that piece out. What I will do is I will not get into that detail. Let me write it out as part of this, right? So orientation is another bit, right? Orientation, say detection, and again standardization, because a lot of the OCR models, these OCR models are trained very well on detecting text, but you're doing something different here. You're looking at tables, right? And these tables have some relationships between them, and now the table becomes vertical. I don't know if existing OCR models have the capability to do this, right? Which is why we are building a baseline. We will have some basic metric that tells you how good this system is, and from there we will look at improvising and improving, right? So image normalization, contrast, equalization, orientation detection, and standardization. I'll put it all under this, but the general idea is going to be that when we get to this actual step, we might need something separate, a separate module or some sort to do the orientation normalization. But apart from that, the rest of it, I think standard image processing libraries do take care of it, right? Contrast and equalization and stuff like that. Right. Cool. All right. From here, I think then we can go to the core model itself, right? Now, when you're looking at it from a baseline perspective, I would say that obviously you having the model like a simple single model that allows you to set up that baseline is good enough. In reality, most ML solutions are pipelines. They will consist of several sub models that they do their specialized jobs, right? But now, okay, that's fine. What we will do is we will look at this and say, I'm going to use a single simple OCR model, right? And here is where the constraints aspect of it is very important. Okay. So what the constraint here tells me is that I roughly have $1 per document, right? So $1 per document means that if I had to process, say 1,000 documents, I have a budget of $1,000 roughly. I mean, that's the upper limit that we'd like to design for, right? So $1,000. Now, $1,000, what does this mean? What this means is $1,000. I know that, so we can look at this from two lenses. The lens I'm looking at is the model that I'm going to use. It has to be, because privacy is an important constraint here, right? It has to be an open source model that we can self-host, right? Now, the moment you say self-hosting, the cost of GPU per hour can be very, very expensive, right? If you open up, let's say, any cloud service provider, and see that I want a 16 GB GPU. We use AWS and Azure a lot. So AWS numbers largely are, I kind of remember some of those numbers. For a 16 GB T4 GPU, roughly about $0.50. Let's assume that $0.50 per hour is the charge, right? $0.50 per hour is the charge. And that 16 GB GPU allows you to fit models which would probably be up to, if I'm using, so here's where you got to understand the nuances of these models, right? Now, when the model goes into production, and I'm not even, see, my model choice is being determined by the fact that I have to do privacy, by the fact that my costing is in here, right? So accordingly, it feeds into the machine size that I choose to keep that machine running. All of this is going to decide my model choice. I can't just be like, what's the biggest, best model out there, right? Because it is with respect to the constraints of your problem, right? So coming back to the mathematics that we were trying to do, $0.50 per hour, right? You can go and check the actual rates. Things could be slightly different, so you can do the maths based on that. But if I were to ballpark it, somewhere around $0.50 per hour for a 16 GB T4 GPU on AWS as of when we are recording this videos, which is about August of 2026. 16 GB of GPU, if I were to quantize a model there's a lot of other production level infra also if you're going for a transformer based model. There's something called as inference engineering, where for you to ensure high amount of, so there's specific computation inside the transformer that is very, very expensive, the attention computation. There's an attention matrix that is calculated. That's a very expensive operation. So there are optimizations done for that. So there's something called as a KV cache optimization, there's page attention, there's a lot of optimization. So this is what's called as inference engineering. It's a part of the ops process. What you need to account for is that if I were to choose a model that takes roughly say 6 GB of my VRAM, I have to give about 2 GB for 2 or 3 GB maybe for all this other inference infra. So that will probably push my total to around 9 GB. Then for the activation function and all the activation layer and CUDA kernels and everything else, for say running one batch, one sample, will probably take me around another couple of GB, right? This video will get very long if I start explaining how I'm coming at these numbers, okay? But the assumptions that I'm making, I can state that to you, so you can go and chat GPT it, figure it out as well, and we'll probably create a separate video sometime to understand this whole inference math, okay? But for now, because you're focusing on design, I think you can go with these assumptions that this is what it is, and then later on we'll of course dig deeper into maybe in another video on why it is this way, right? So it's probably good for me to write down some of these things, right? So as part of our design notes. So what I'm looking at, so I'm trying to size my model first, which will fit my privacy, cost, and all of these constraints. That's what I'm trying to see, what kind of range and sizing of my models I can go with, right? So I'm going to go with the assumption that let's say if I choose a model like a 3 billion parameter model, will consume, right? I hope this is visible to you, right? Will consume at a FP16, so 2 bytes per param. So this will roughly be around 6 GB approx. Okay, will consume approx 6 GB VRAM at FP16. Okay, 16 bits, 2 bytes. So therefore, this should be 6 GB roughly. Right. Plus this, I said that there's a lot of inference level infra, which is like you have the KV cache and other. So say, let's say CUDA kernels plus I'll just write this in the bracket plus CUDA kernels, etc. Is another say 2 to 3 GB. So let's put it at roughly around 3 GB. Plus you will also have like activations, right? So activations and few other things in there, right? Which I think will be another say couple of GB, right? So what this puts me at is 6 plus 5, roughly 11 GB is consumed if I go with a 6 GB model, and the space I'm left with is about 4 or 5 GB, which means that I will be able to process say 1 or 2 pages, okay? 1 or 2 pages at a time in a single batch, right? Each page roughly taking, activations are 2 GB, so each page will roughly take about 2 GB. So which means that I can process about 1 to 2 pages, right? So we'll have to verify some of this math. It's been a while since I've done some of this math, but I think you can verify this at roughly a 3 billion parameter model. I might be a little bit off. Okay, I might be a little bit off because I'm doing a lot of back of hand calculations here, but 3 billion parameter model with the KV cache, CUDA kernels, activations, everything will roughly be something which fits on a 16 GB GPU, and that GPU basically costs us about so this whole ecosystem. So I will say that I'll be choosing this sort of a model, right? Choosing a 3 billion parameter model, and this costs us about $0.50 per hour, right? And why is this $0.50 important also is something we will see, right? So if this costs us $0.50 per hour, okay, right, so it costs us $0.50 per hour, and Okay. The other bit here is, because you're saying it's cost $0.50 per hour, we need to know what is going to be the processing time of these models, right? So in 1 hour, so roughly I'm saying that I'm okay with under $1 per document. So in a single hour, how many documents am I going to be able to process is something that we need to know, right? So that will decide the costing, pricing, all of that, right? So we have said I'm going to choose a 3 billion parameter model because that's going to cost roughly about $0.50 per hour. And these OCR models, right? So here is a point where you need to go and understand how much time is it going to take for a single page in an OCR model, right? And we have decided to go with an OCR model because it's scanned PDFs and they work well on scanned PDFs, and they'll obviously do reasonable on digital PDFs as well, right? So it is at this point that I will probably give you a little bit of information. These OCR models, because they are running page by page, right? You can use an OCR model, you can even use a VLM, vision language model, right? There might be a slight difference in terms of the quality of outputs because OCR is more, I guess, tuned for text, and they could do better on tables also if you have specific OCR models that do very well on tables. VLMs, I'm guessing, might be a bit more general purpose and might do better on I don't know. It's tough to say. It really depends on the model and the kind of training data that's been used. But VLMs are another option, right? In fact, okay, all right. So I don't want to get ahead of myself. So we'll come back here and I'll maybe add some information here, which is each page, let's say, takes around 10 seconds. Okay, and this might look like a lot to you, but the reality is this: that these OCR models, in fact, take some time. Right? They do take time because it's scanned images that it's working on. It's in large number of pixels that it has to process. And if you try to make the pixels, if you try to make the image smaller and you try to use these OCR models that work on small images, your accuracy also drops a lot. So if you say you wanted to work on a 64 cross 64 or any kind of really small images, because it's seeing fewer pixels, it will not be able to get those nuances. So you wanted to work on larger sizes that in fact many of these are trained for. So each page in fact takes actually 10 seconds because you're processing a lot of pixels there, right? So 10 to 12 seconds. I think I'm adding 12 seconds here because it would make the math a bit more easier, because I'm saying that we are going to have total of 10 pages. So total processing time would be say 12 into 10, which is equal to 2 minutes, right? So I'm saying each page is going to take 12 seconds. We went to the assumption here that we'll be having, say, 10 pages per document on an average. So average processing time per document would be 2 minutes, right? Now with these assumptions, look at all these assumptions and the commentary and everything that we're looking at, right? See, there's so much amount of, this video has already run about 47 minutes in, and there's so much that you need to do even when you're having this discussion while designing the pipeline. Right? So this is what will kind of make it complete. And today, of course, you have a lot of AI tools where you can fast track this discussion, right? If I were to spin up Gemini and quickly say that this is how I want to approach it, and you build a template for yourself, you'll be able to move through this much faster, no doubt. But for that, you need to know the process well, right? And for you to do all this research on, okay, what's going to be the parameter size, what model then fits these requirements, right? Etc. etc. You can obviously use a lot of these AI tools so you can move much faster. Okay, so what this means is that if I were to process 1,000 documents as per these specifications, it would take me 1,000 into 2 minutes per document, so 2,000 minutes. So that would be approximately 35 hours, right? Somewhere around that. 30 hours is well, probably not 3, but yeah, so 30 hours is 1800 minutes, so we'll be somewhere around that, right? So for 1,000 documents, 2,000 minutes will be somewhere around that, 33 hours. And the 33 hours, so if you're running this machine for 33 hours, what is the costing going to be? The costing is going to be $17.5, right? $0.50 per hour. I'm running for 33 hours, $17.5, right? So this is actually giving me a complete picture that if I were to choose now this sort of model with this infra, right, this is going to be my costing, and this is going to be the total runtime of that, right? So accordingly, now you can also decide when you get to on an infra level, right? And all these things should be running in the background of your mind before you move into development, right? That now if I were to do any kind of load balancing, if you want to move to a real-time system, right, what is it going to take? How many do I need to process in parallel, right? Over here, one thing to point out is that the amount of space I have left here is not much. If on a 16 GB machine, I probably have 4 or 5 GB left. My KV cache here plus all of this is roughly 3 GB. So if I'm having about 5 GB, 6 GB left, maybe I can process one. I'll probably write that in here, right? So we talked about the cost, which is here, which is that if I choose a machine that is say 16 GB VRAM, we have approx what is the math here? 6 plus 3, 9, 11. So we have approx 5 GB, and the KV cache and these CUDA kernels, if I were to assume they take 3 GB, then I have roughly about one page I can process at a time. GB, which can process one page at a time. Okay. All right. I hope the process makes sense, right? So according to the constraints that we looked at, the cost of processing per document is under $1. It's much lesser, right? Because 1,000 documents is $17.50. So we're doing very well on the costing, right? We are doing batch processing. 1,000 documents per month can easily be handled. Each document having 10 pages. Privacy is taken care of because we're going to self-host this model, right? And what they're saying is there's probably 2 to 3 documents which can be sent at a time. So we will have to see some kind of infra on that side. So there'll have to be some scaling which will be required to process these documents in parallel. So in which case, if I was sequentially processing these documents, this is what would be the time. If I'm looking at say certain documents in parallel, then the costing would accordingly go up, right? So if I say my max scale is maybe say 5, right, or 10, maybe 10. If I were to say 10, essentially what I'm saying is I would be reducing the per hour pricing, but I would be increasing my parallelism and speed, but the costing would be slightly different, right? I don't want to get into too much math because we've done enough math here for you to give a ballpark number, right? Now you know that you have much more headroom. If I have much more headroom here, because now my processing cost per document, they're basically telling me I can do $1,000, right? But I'm doing this at $18. So I know I can use much more powerful models, much more bigger machines, right? You can say that instead of using a 3 billion parameter model, I can now use a 30 billion parameter model. Roughly, if I were to linear scale this would be $200, right? Around the $200 mark. And you know that if I were to 4x that, I would be 4x or 5x that, because many of these things don't completely linearly scale. Right, because the CUDA kernels and things could be slightly different, right? And depending on your batch size and how you want to process all of that, it could be slightly different. But for the sake of simplicity, if I were to assume this is completely linear, I know that I could go with a model size which is roughly 40 times this size, right? Roughly 40 times this size, 40 to 50 times this size would still work for us. So that is the capacity that I can in fact play with. And now you know that, all right, if I were to go to 40 to 50 times this size, then accordingly, this is for single processing, right? Which is sequential processing. If you are looking at processing 2 documents at a time, right? So here's a call that you have to eventually make on an infra side, saying that if I were to, a larger model will be much more accurate for me. So the costing will only make sense with a model that is 40x the size. And then you have to do sequential processing, then you let them know you have to do sequential processing. If you feel that you can find a model that is maybe 20x the size, that will cost half for a sequential processing, you can tell, okay, I will now relax sequential processing. I will now be able to do parallel processing, because now I can 2x the number of machines that I'm going to use, because my model size is only 20x, not 40x, right? So you can have these discussions and then eventually come at an agreement on these are the trade-offs. This is my ecosystem that we are going to work with, right? Really long discussion, but now you have a universe of models to choose from, right? I went with the 3 billion one because it's a little bit easy to see if you want to fit it into a single machine. The other bit also is we said privacy here, right? Now, if the end product is in the Right, okay, let's not get into it. I think this already suits our privacy needs. If you want it to work on a person's phone and things like that, then sort of a 16 GB kind of a VRAM allocation, it's a little bit on the higher side, but it still can fit on some of the more premier phones and things like that. And of course, you will have different kind of processing in there. If you work with these iPhones, you have like the metal and the GPU components in there that work slightly differently, but it has that unified memory if you want it to work on some of these Apple devices and so on. So the math becomes slightly different, but 16 GB is a good way for you to start out with, because this is probably the first video that you'll be viewing. Now you will be able to do a lot of this back of the hand calculations to immediately say that, okay, now if I were to have this kind of size and this kind of stuff, then automatically a model that is say 100 billion parameters is something that we should go with. Your intuition will start getting faster and faster as you do more of these exercises and you understand the math behind this. Okay, for the sake of simplicity, I will just go ahead with these assumptions, and I am familiar with certain models. So there's the Quen family of models, DeepSeek models, which they build some really efficient models that work on small compute. Okay, for a lot of teams, that's very, very important because costing is a major bottleneck. It's a first class design decision in the LLM world that you live in, right? Cost. Okay, so for that perspective, and since we're building a baseline, that's the other bit, right? I don't want to go the most expensive, the best model right now. I just want to go from problem to solution. If it's going to be easy for me to pick this model, put in a single device, right? That's the other challenge, that if I'm going to choose a larger model, I will not be, when I'm doing my development also, I'll not be able to do it on a single machine. I'll need the machine of that scale, right? 4 GPU machine to run a model even 4x or 5x this size. Of course, development time, you'll not have all the other infra. You're not going to have the CUDA kernels. I mean, you don't have KV cache. You don't have all the inference infra. But yes, I hope I'm able to give you a breakdown of the thought process that I'm going through while I'm designing this system. Okay, that is the larger aim that I wanted to bring out through this video. And now we'll move a little bit faster because I think we've done a lot of the math, and because I am familiar with, say, the DeepSeek models, we will now say we'll use the DeepSeek OCR, which is let's say a 3 billion parameter model. Parameter suits our requirements. Okay, so after this image normalization step is done, I will now say that I'm going to give this as an input to my OCR model. Right, of course, in models here you can actually search for some specific models. Right, this is a library which is where it's sort of in progress. We are trying to add more and more models by default. As of what I remember, OCR models or DeepSeek models, DeepSeek V3 is in here, which is a mixture of experts model. So the beauty of this is, in fact, if you, I think the article is not yet there, but you can actually look at some of these models here and it'll tell you whether this is proprietary, this is open source, how much is the approximate processing time. So we try to add a lot of info around that, but obviously this library, we're just starting out on the library, so it's not very exhaustive. You can always, create a custom block like I am doing here, right? So you can just say that I'm going to use the AI model for this is the DeepSeek OCR model. Now this is a 3 billion parameter model, and at FP16 will take us 6 GB. So when you're actually doing development, you can use a 8 GB or like a sort of smaller machine. You don't need a 16 GB machine, because it's not just your inference cost which you should keep in mind, it's also your development cost. During development also, it's good to be efficient, especially if you work in smaller teams with lesser budget and so on. And even if not smaller teams, if you're working in a part of larger teams which have bigger budgets, but you're doing a lot of exploratory experiments, right? There's a lot of like R&D that's going on. It's good to be on the more efficient side, because you can always scale up when you know when something works, right? Right. So this is what it is. Now for this DeepSeek model, right? These OCR models, these are also these are models where OCR models have also evolved. Many of them do have the VLM style of working where you can sort of give an input prompt. And I would like to design a specific prompt here that says that I want you to extract the balance sheet and P&L and cash flow. And balance sheet looks typically, I would like to give it some domain level information here, saying balance sheet typically looks like equity and blah 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 blah, and P&L typically looks like blah blah blah, etc etc, right? So this sort of a little bit of a knowledge base to this whole process. Okay, so I think with that we would have gotten the basic model itself in here. So we, I think, have our basis covered. So this is the AI model, and this model now is going to give as an output. You also need to mention what is the kind of output that you're looking for, right? Because these OCR models, as you do research, you will figure out what, depending on what universe you're working in. The OCR models, they sometimes give output as markdown, some give as JSON. So you need to be specific on what kind of output you are looking for and convert it into the specific format you want to work with, right? So that's also very important. So in the prompt itself, you will mention, oftentimes they come with like template prompts and so on. So you'll mention that I'd like the output as a markdown. Okay, so they'll be trained on these specific modes which allow us to get specific kinds of outputs, right? So that's how these models would be trained. And once you get the output, right? So now you think, once the output that comes out, it's probably, I would say, not completely correct always, and you can inject some sort of domain level verification, right? You can go back and tell folks that this is what I'm getting. So we know the balance sheet should tally, certain things should sum up inside, right? It would be nice to add that as some sort of domain information. So that can be added prior in the prompt itself on the input side. What I've also seen as a design that even sometimes we have adopted is that you have an additional module in here that does some of the structured math and at least verifies the quality of outputs. If this is going to be human verified, then we can give some probability values and confidence intervals so that the amount of verification the human has to do will have to be lesser, right? So we give them only specific samples where we feel maybe certain things are not tallying, certain things are not extracted correctly, etc, etc. So it becomes easier to do those sorts of things, right? Now what I will say for now is that I would like to have this is now going to produce an output which is sort of structured markdown. Okay, structured markdown, and this will have like titles, tables, basis, financial statement, right? Yeah, I think that's good for now. So we just connect this to this. Awesome, right? There are a lot of other aspects to this design. Okay, a lot of other aspects to this design. I'm just wondering right now if this is a good time for us to get into that or not. So we have right now built a baseline. This baseline is not complete from a lot of different ways. It's not complete from a production perspective. It's not complete from, say, responsible AI perspective, because you don't have your other detectors in there, and also like feedback perspective, right? When you're saying I want a human in the loop or have some sort of feedback that's in there, it's not complete from that perspective as well. Okay, so what I'd like to do right now is we'd like to add all of that. Yes. But before you do that, we can just evaluate this pipeline as is. Okay. If I hit the evaluate button here, it's going to give me a poor score, and we will work through this because there are other things that I've talked about that we will add for sure. Our evaluation in here is, it sometimes has a little bit of errors in there, so I'll just hit it anyways. So sometimes it doesn't work currently very well, which is why this is in beta and we're working on it. But if you kind of click on the button multiple times, it will kind of show you an output eventually. So while we fix all of that, you'll kind of see some of that in action right now. But I decided anyway to go ahead and create the video because we want to get into the process, right? The process of you understanding how this entire ecosystem works. Okay. So while the evaluation is going on, let me walk you through what we need to look at from a production perspective, right? Few things from production perspective, very obvious pieces that would be good to add is we probably have to serve this as some form of an API, right? I think there's a backend failure, is it? Okay, let's see. Hopefully this evaluation goes through. Okay. Yeah. So coming back to the production perspective, we have to serve this probably through some form of an API. And since we said we want batch processing here, there'll be again some sort of a queue. I'm guessing that will have to be added in here, right? So it is good to start exploring adding those sorts of elements in here. The other part here that we also discussed about is concurrency. So which means that you probably will need some form of load balancer with auto scaling and all of that also in there, right? So we can start adding those elements in here. Right, so there you go, perfect. So you get there's a score that's come in here that says 3.5, and we'll give you guys access to the product itself, and you can hop on, log in, and try to play around with it. Just give very specific feedback and follow-up questions. So what you want when you are getting your design evaluated is you want open questions on what you have missed out, right? I have already outlined some of the things that we have missed out, and we'll add that. But I'm hoping that, the specific aspects here, that the 6 items, line items on which you are being evaluated on, they also bring it out, right? So from an ops perspective, it says there is no deployment, auto scaling, CI/CD. We already have that, we already talked about adding that in, right? Responsible AI, nothing is added, right? No bias detector, etc., etc. Production perspective, flow is good and streamlined, but lacks caching, load balancing. We talked about that as well, right? Model building, it says we have done sort of something decent. We started off with something decent. Something particularly what I love about this specific tool, and something which people miss out a lot. We spent about an hour talking about assumptions and sizing models and all of that, right? The assumption analysis and follow-up questions. These are I think very, very golden pieces. Follow-up questions, if you look at it, right? It really looks at things that you have missed and gets you thinking. You don't have an actual interviewer or somebody else to talk to here when you're in the system, but when you hit evaluate, these follow-up questions get you thinking to improve your design. So things like, hey, do you intend for the system to serve live inference requests or only offline batch processing? We said batch processing, but I think it's not mentioned anywhere in this design that it's going to be batch processing. There's no infra over here for batch processing, right? So that question is warranted. How should ambiguous or low confidence extractions be handled, right? Human review, both very valid questions, right? Will make your design again complete. How do you add explainability traces, right? Important questions, right? Now you look at even assumption analysis. It says some of the assumptions we have documented, certain assumptions we have not documented. What kind of accuracy targets are you looking for, right? I very loosely told that we're going to be doing LLM as a judge, but I didn't mention specific metric, right? At that point in time, I did evade that, but you should add that in as part of your design. Okay, so that and so there's a lot of assumptions which are being questioned. If you have assumed certain things, it will come in here, which is something I personally love constantly, right? Because it oftentimes brings out a lot of stuff that we just think is all right. Then in terms of feedback, it does tell you what are some of the missing components, and you can use this independently to improve your design skills. Okay, so anyway, so this apart, I'm going to close this because we already discussed some of these pieces and we'll go about it in our own way. So what is important for us is we need API endpoints, right? So there are some standard things in here. So I would add a API endpoint in here. The idea here is that this specific API endpoint takes the scanned PDF as input, right? So this is what would receive the specific request. Now to this API endpoint, I would probably need, depending on the load, I would, we need something to queue because we're doing batch processing, right? And we also need some form of auto scaling plus load balancer, right? So there is these components, many of these components are already in here. So there's a load balancer in here. And what I would say is, I'm going to consider this as handles concurrent traffic and includes, let's just say it includes auto scaling, an auto scaling component in it, right? So let's say it includes that. So you're going to say this is connected to a load balancer, and then from here I will probably need a job queue. I don't know if you have a queue in here. Queue is not there, so I'll add a custom element here, which is the job queue, right? So job queue, this is for batch processing, and it's important that this job queue, one is we're talking about the entry point. Entry point is the moment API request is sent, then something's added to this job queue. Also the job queue should get updated on completion of task, right? So it'll also get updated. So there has to basically be some form of a loop from the output, and we'll talk about that also, right? So we got in the job queue here. Amazing. The other pieces is that usually as part of not just infra, we are looking at, like image normalization. We've done some pre-processing here, but what needs to be taken into account is that sometimes when you look at it from production perspective, you have to look at some of these edge cases, right? And sometimes you need a mechanism to reject specific PDFs or do some form of data validation that this is a valid piece of input, right? So validity of input, for that we'll add some data validation in here, right? So your input basically passes through all these, you can actually do that. So the training and inference also here is an interesting feature that we are working on, where, if you're having certain parts of your pipeline which are only exclusive to your training and you don't want them as part of your inference, you can just like right click and say, I want to exclude it from inference, or just by default, everything is included in inference, right? Right now, we have not done any model training. The idea is in this baseline, I will just connect this. So in this baseline, we want to move as fast as possible, right? So load balancer, we've got in the queue in here. We've got in data validation also done, so you know what to reject and what to accept, right? So on the rejection front, we would probably have like a separate block in here that says, let's add a separate block, right? Gives output, I could probably write something like if invalid input rejection response is sent, right? So that's on the rejection front. If it is accepted on the acceptance front, we would say I want to now go to the rest of the pipeline, right? So I'll probably remove this input scan PDF because now this is coming as part of the API endpoint itself. Ideally, if there was a left-hand thing in here, I would have put it there, but it's not there, so I'm just going to assume that it's coming in from here, right? So I'll probably change this to say for valid inputs, proceed with this. Okay, so now what we have done is we have now added in a lot of the input level infra which is often required, right? It's a great first step here. What is also required is you understanding what is there inside this model, correct, and adding model specific infra. So these like, let's say we're using the DeepSeek model in here, right? And this would require a KV cache, and there are all these libraries that allow you to do this inference engineering. So VLLM is one library. I think NVIDIA has another one. I think it's called TensorRT. I've not used it. I've used VLLM more. Fun fact, VLLM I think came out of Berkeley as a just as an exercise, as an open library, and now has evolved into what it is today. So you have a lot of that infra, which is in terms of KV cache and page retention and whatever else is required for you to deploy these models efficiently and do that attention matrix computation efficiently, make your inference cost also lesser, etc., right? So all of that is required from this models alone perspective. So that is something which I will add in here. What also you need to add from a general pipeline perspective is that you no longer just call the model directly. Usually there is something which is very unique to machine learning pipelines, and it is different from traditional software, is data, right? Data and your models. So data and models both require versioning to for them to work well, okay? Because you are now building a baseline, yes, but in subsequent versions you might have a custom trained model, other pipelines and things like that, right? So your input which is there doesn't necessarily come directly from the model itself. It would come from the model registry, okay? So that is an important piece for us to add. So this is called as the model registry. Right? So some of the standard pieces we have already added in here. So the model registry is for managing any kind of versioning of these models, okay? So I will probably knock off this specific edge here because we are not giving it directly as an input here. We will use the model registry, will then retrieve accordingly the current version of the model we are looking for. So on the infra layer, when you set it up, you have to set up all of this, correct? I also talked about the other peculiarity or uniqueness on the inference engineering bit, which is, I don't know, have I already added a KV cache here? We have not added a KV cache or any kind of inference engineering piece in here is probably not there. So I'll add that in here, which is that we will need inference level optimization, which is things like your KV cache and inference optimization. Right? So this inference level optimization will be there within the model itself, right? So what I will do is this allows you to like efficiently choose the respective models, run through that, etc., etc. So I'll knock this off and I'll probably add this in between here, right? So we move the model registry out here, we get the KV cache and inference optimization piece in here. Okay, so from the model registry, you are not just retrieving just the model, but you're also retrieving the cache and the optimized version of the model ready for deployment, right? And the normalized image which is there would then go over here. Okay, so this is what. So we're getting closer and closer to the end. We're almost there, but we're not completely there yet, right? So some of the inference infra has been added, not all of it. Right. The other most common inference infra that you will need is for monitoring and observability. So for monitoring and observability applications, performance monitoring is not what we're looking for. Any kind of observability stack items in here. There's an LLM gateway for routing. Okay, about 195 blocks in here, but we're trying to make it much more exhaustive. And as we do more of these exercises, I think it will automatically start getting more exhaustive. We'll add them to the default blocks in there, right? So I'll treat it now for the sake of simplicity as a custom block where we now need a monitoring stack. Right, so I will just call it as a monitoring and observability stack. What this largely does is it is you basically need some form of, say, drift detection, okay, which is whatever output that you're currently getting right now. If the kind of inputs that are being received is different, you will start noticing that. So there is something called as concept drift and data drift and all of that. So drift detection algorithms need to be there to notice when the performance of your pipeline starts dropping, and that will have to trigger retraining, right? And sometimes, you know, there's automated triggers and automated retraining that some pipelines kind of undertake. We can do it in a much more simplistic manner where we want some human intervention. We want our ML engineers to still have their jobs so they can go and look at what's actually going wrong, what kind of, you know, is it a data problem, is it a model problem, right? What do we need to do to get the pipeline performance up, right? So we add drift detection in here, and I would say also say any kind of retraining triggers, right? So that all comes as part of your observability stack. And as part of the observability stack, right? So monitoring one piece, as part of the observability stack, we also need to add in responsible AI. And what I mean by that is, we'll kind of, let me mention that, right? So this is basically taking care of a lot of your logging, right? Observability stack is also taking care of a lot of your logging, right? So because that is what allows you to do a postmortem to understand what's going on in the pipeline. So logging comes from what your model is producing, right? And it's very, very important that you add some of these standard detection in your outputs to see. So you add, let's say, like a bias detector. What else? You add maybe this specific item. Content moderation may or may not be required, but you can add content moderation also in here, because what if some kind of rubbish input still passes through a data validation and some kind of harmful output is predicted, right? Also, I think you will need something which, so content moderator is one piece, but you're going to be working with financial statements. So depending on who the end user is, it also depends on that. There's something called as PII, which is basically personal information. What kind of information should be exposed? Do you want it to be like blackened out? If you're having like company names, director names, right? So these are also discussions that you need to have on who's the end user, what kind of information that you're going to expose to them. So in general, I would call, I think there's a privacy filter of some sort here, differential privacy. There's a privacy filter here. So we can add a content moderator, we can add a privacy filter. So we do all this. Essentially we do all this to ensure that you are now having safe outputs, right? So these are guardrails which are added to your system, which otherwise would not be part of. So this is why when you look at a production stack perspective, you need to ensure all of this is in there. Okay, so you need to ensure all of this is in there. So what I would largely need from here is I will take the output and I'll pass it through each of these. Accordingly, we will see what happens to the output. Right. So obviously all of this would kind of go into might be easy for me to put the content moderation at the end because it has multiple outputs here, right? So we will knock this off, we will get this here, right? One set actually of outputs here go to the monitoring stack, right? Because now the monitoring stack will do and basically have all the logs for you to analyze any biases in your system, any kind of privacy issues which are there, etc., etc. The other bit I would probably say is that this whole system you need to figure out. Right now we are looking at it where we don't know how accurate it is, right? So it's like a version 1 you're building off with an off-the-shelf model. So given this is what you're trying to do, you should probably have a human in the loop. Okay. So we have added a human in the loop. I think I remember that. Yes, we have a human in the loop here, right? So the output which is there should probably go in human in the loop. For specific samples, let's say you want to set across some confidence intervals and so on. For specific samples, you have a human in the loop. And once it passes through this person, we would then have the final output. Right, so I would call this as the final output once it passes through the person and they have corrected or vetted or whichever way you want it to happen, right? So this would be the final output. I would say after post processing and human review. Great, awesome. So you have now come at the final output. Okay. I hope I have not missed out too much, but if you were looking at it largely from a baseline perspective and you just want to add the basic inference infra and all your respective monitoring stack, this I think largely looks good, right? So this monitoring stack also should influence completion of tasks. I presume your job queue should be updated once things are added to your monitoring stack or things are added from your final output. So you got to decide how do you update your job queue also. I don't want to add a loop here and make this diagram look very messy. But this I think is a good version 1 where you have not just developed a baseline in isolation for your development purpose, but you have also gotten a production quality pipeline which now goes from input to output, including all aspects that are covered, right? Baseline has been established. This will have some version 1 accuracy, right? I'll just hit and evaluate here, and while this is happening, we can have a further quick discussion. So how do you move from here, right? You've already chosen some base model because it's easy for development and you want to go from problem to solution, and the interest is speed. Great, awesome. You now look at what are the outputs of this model, right? And when you look at something which I hinted to earlier, when you look at these outputs, you know that there is a structure to these outputs, unlike text. Typical OCR pipelines have been trained on text. So one is, it is questionable. You'll have to look at not just the quantitative numbers, but the qualitative outputs that you're getting. And you will probably notice that, great, you can already see the score is up because we've addressed a lot of these things, right? So before I get into the scoring and what it's actually telling, so let us discuss a little bit more. You now have to see what is it that you're looking for from a verification perspective, because now you know the tables have certain things that sum up to them, right? I did hint at having like a manual intervention where you have a little bit of some functions in there that do the math and do things like that. But it would be most effective in my mind if I were to be able to feed that back to the model, and this model can then regenerate basis that feedback, right? So that kind of loop would be really nice, right? That's one possibility. The second thing is that they could be really bad at layouts. Okay, so when you look at the outputs, it will give you insight into which direction to take. And these are some things initially, as I look at the problem, as I look at OCR, if you have a little bit of understanding around OCR, you'll probably understand it will probably do a little bit poorer at tables. And the other bit is, these financial tables are really long. They can run into multiple pages. And when the tables are disconnected, there might be some post-processing which might be required, right? We have not looked at that at all because we were just looking at building a baseline here. So some kind of post-processing, some kind of layout detection, because these OCR models would not be great off the bat. So those are two possible improvements, and a verification layer if that could feed back into this and improve this itself, right? So all of this apart, all these which are there are pipeline level improvements, and we are still not training any model. That's what I want to bring to your attention here, right? Training, the moment you get into training models, you obviously have some 20 samples here which will get hand labeled. You can use that for evaluation and looking at how good your model is. You can tune the prompts, you can do all of that. Get a pipeline to do, I could, if I want to look at a subsequent iteration, I could do one thing where I say, okay, now I just don't do directly OCR. I have a layout detection which looks at these pages, because typically if the input is something like an annual report or those sorts of documents, you will have text interspersed with the table itself, right? You're going to have text interspersed with the table itself, in which case I will need to identify where the tables are. So you can have some layout detection model as a starting point here, and you could then go and look at OCR model, right? So you're no longer just looking at a single model. Now you're looking at a pipeline, right? So that's one direction you could take. Adding some sort of a verification player in there could also, again, you're not training anything, right? Training actually comes as the last alternative, right? Once you establish this baseline, have some basic metrics in there, see what you're working well with, see what you're failing on, then is when you probably would look at the question of you training the model for some specific use cases. If whatever that is there that you can do from a pipeline level innovation doesn't address your needs. And even when you do training from scratch is very painful. Make sure that you fine tune with some limited number of label data, because the amount of data that you need to label will be lesser. If that is lesser, you have tighter quality controls, so you can ensure the data is correctly labeled as much as possible, rather than having 10,000 samples. If you have high quality 1,000, 2,000 samples, 1,000 samples, you can do a very good job. You can fine tune these models on the specific kind of data that you're looking for, right? So that would be my recommendation on you iterating on this pipeline. So if you want to iterate, make a look at the outputs. I'm just restating this. Make a look at the outputs. How good are the outputs? You will probably get insights on maybe the layout is bad, so you can pick another model which is a layout model. But the moment you do that, remember that some of the constraints here will change, right? So you add a layout model, you will notice that your constraints will change, your processing time will go up, how much you get to fit on the memory, you might be able to have only a 3 billion or a 5 billion sort of model in there. if you want to fit it on a single GPU still, but you have good amount of headroom in terms of cost, right? So that's also the other advantage in terms of cost, that on day one you don't choose a largest model, because at the end of the day you might have a pipeline, and this pipeline will probably have to auto scale, and at the grand scale, that is what your budget is, correct? So for one page processing, this would be my cost. If I want to have 10 pages being processed and 4 models in there, the costing would be very, very different. Okay. What I will do right now is that now that we have the result here, we can take a look at what we're doing well on. So looks like the evaluation is pretty happy with our model building. We have built a pretty solid model in here. It's happy with the data pipeline, right? It's of course mentioning that you can have a little bit more richer metadata based lookup. That's very, very interesting. Rather than just the OCR bit, you can have some kind of metadata in there, which is not something that we were thinking of when we looked at the initial design, right? For a baseline, this works perfectly fine. But now when you're looking at iterating and building something superior, you can now understand that, hey, I can also have additional metadata on what is there in this document. If that's also can be fed in, any handwritten notes, anything extra about it, right? It'll obviously help. It says we are a little bit short on the responsible AI, probably because the explainability component is not in there, which is great. You can also add an explainability component in there, but do note that explainability can be a bit challenging when it comes to these OCR models, because what it is detecting, how it is detecting you. If you want to give that transparency to the user, it's pretty tough from the deep learning world. You can do it from the classical machine learning world in an easier manner, but you can maybe establish some traceability, saying that this first half of the image is where it got this from, and things like that. So there is some things that could be possible here on that front. It's pretty happy on the production and compliance front. There are some follow-up questions which are coming, which is what kind of acceptance thresholds for quality. All great follow-up questions. You can dig deeper into this, right? Are you looking at automated developments, or when a new model version is coming through, what is your process going to look like? Correct. Amazing stuff. Good questions to answer. Again, on the assumptions front, we have not talked about SLA around availability, recovery, serving stack is not documented. Sure, right? As you get into more on the production level items, you can sort of look at that. Are you looking at automated drift detection, explainability components like Sharp and Lime and all work well for classical machine learning. Attention visualizer actually is a pretty nice touch when it comes to these transformer models, because that might give some insight on what parts of the input it is paying more attention to for this output. Yeah, so that for sure will give you some kind of explainability in there. So that's the overall feedback that you're getting on this design, right? And I've also given you directions in which you can iterate. So let's do one thing. This video has already been pretty long. Hopefully you got an idea of the process. How do you build your baseline, and how do you add a production stack around that? So what I will do right now is that we can maybe add a simple one iteration. Right, let me do one iteration in front of you, and the iteration that I can do is, maybe because agents are all the hype, and you can move to an agentic setup here without having to train anything further, right? So for that, what I will need is that I would like to probably look at adding a verifier agent, right? So here I'm having a generator that is generating whatever it is generating here, and what kind of agents do I have in here, right? So role-based agent. So let's add a role-based agent here. So specifically, the role this agent is going to be doing is that it's going to be a verifier, right? So we will add that input in here. This is a verifier agent that gives feedback on the quality of output. Quality of output, right? Now this agent, you will receive the input from here. So this input directly doesn't go here, so you will receive the input from here. Okay, awesome. And this will of course feed back to the input, right? So there are different agentic patterns that you can study. Amongst the simplest of patterns are the generator verifier patterns. So here you have a model that is generating, here you have a model that's verifying, and I've added a loop back between the two of them. So they'll probably go through, you can set a specific loop limit or a quality threshold on the basis of which you can say I'm happy to exit this loop, right? So the loop can be a bit confusing to view. but basically there's a loop in here for this verifier agent, and we should probably add that in, right? We should probably add that component in here where the which basically says that exit at 3 iterations, right? Exit at 3 iterations or a quality threshold. Okay, so I think that's the additional piece here, which is this should probably go here, right? So this goes here, and then the final output in fact would come from here rather than where it was earlier. There you go. Perfect. So now you're done essentially in another iteration, and obviously the constraints over here would change. You basically would say that I am so after the baseline I'd like to add a I'd like to convert this into an agentic setup with a verifier agent. The generator will be the DeepSeek OCR model itself, right? Great. And you can discuss further about the specific nature of the feedback that you want to add, right? And what does quality mean? So there's a much more deeper discussion that you can have on each of these aspects. And if you look at it from an interview perspective, that's what people also dig into, right? They'll say, okay, walk me through this, right? Walk me through why you're doing this. What's the premise behind it? What are some other alternatives, right? You want to look at trade-offs, you want to look at all of this. And the important constraint here is that this verifier agent, this is also a language model, right? And again, if I wanted to fit on this 3 GB, again, I don't want to get into the large calculations of it, but I'll say that I'd like to use an SLM. Like, I know the Quen family of models are really efficient. I think they have like a, I don't know, they have like they have some 3B, like a vision language 3B model. Okay. Some 3B vision language model they have. So that will basically take up another, probably I'm guessing 5-6 GB, right? So you're pretty tight already on the 16 GB here. So you might have to upgrade, or might for sure will have to upgrade to a probably 24 GB machine, right? So the costing for that also will be accordingly higher or a different basis that, right? Okay, cool. So I think now we have most aspects covered, and you can continue iterations. And from a pipeline perspective, right, and whether it's an interview perspective or you just getting an idea of what you're going to build, this is, I think, great. It is, in my mind, not worth going through more than 1 or 2, maybe 2 iterations over here when you're building this out, primarily because when you actually get down to building the system, the learnings from there will automatically dictate which direction you should go in. Right now, I added a verifier agent. I could add another like layout detection in there, and the constraints will constantly keep changing basis that. But once you have a baseline established in my mind, and you have the entire production infra ready, and you know all the constraints, the problem and the solution itself that you have will guide what direction you should take in, right? Yeah, so I think that should be sufficient. I can reevaluate this. It might give me a higher or lower score. Most likely it'll give me a lower score because the moment you add an agentic pipeline, there are so many other things that need to be considered. So there might be a few other like missing elements in here. So I'm not very confident it's going to give me a higher score. But all the same, what you can do is you can sort of save this in here as version 1 of fin statement. Right, and the beauty is that you can in fact export this design, right? We have built this to be a very general purpose tool. So when you export this design, it will get exported as a JSON or a PNG. So the PNG can be used for your internal purposes if required, as part of your development and your internal team discussions, and or even for your interview preparation. The intent actually here is more so on the interview preparation side, but then it's also very, very useful for your internal discussions as you build stuff in your team. Or you can export it as a JSON file. The advantage is you'll get everything from your commentary to assumptions to this will basically render as a graph, and you can now give the JSON file to your favorite AI tool to do whatever additional manipulation, get more evaluation of your design, work with saying this is what I have, can you convert this, give it to Claude Code and your agentic coding pipelines and say, now I want to convert this into a pipeline. And you can have further discussions on planning different phases of implementation and things like that, right? So the export feature here is very, very useful once you get the JSON schema of everything in here. And from an interview perspective and from a completeness perspective, you can look at it for these follow-up questions, assumption analysis, feedback, etc., etc. And this is how I would say the theory and the framework that we talked about, we are putting that into practice by looking at it from all these lenses. I know this is a super long video, but if you have stayed till the end, I'm hoping that all the nuances and discussion and thought process that I went through in designing this, that I was able to expose you to some of that, because not everything comes out as part of notes and as a slide deck, right? In passing, I would just end up saying things that hopefully adds value to a lot of you. So that's it from my end. If you guys have any questions, feel free to drop it in the comments. You can go ahead and review the other videos on machine learning design frameworks around that, evolution of agentic design. We'll probably look at doing another such problem with more of a focus on, say, agentic pipelines, because that's a little bit more relevant to what a lot of people are attempting nowadays. And we'll also drop a link to this tool so you guys can try it out. With that, if you have any other recommendations, suggestions, if I've made any mistakes in the whole video, feel free to point it out in the comments. We'll try to get it corrected. I did this pretty much on the fly because we were looking at launching this tool pretty quickly, and and I thought it's going to be of very high value to a lot of you guys who are preparing for interviews, and we saw a lot of questions coming on Reddit on all of this. So best of luck. I'll catch you guys in the next one. Have a great day, guys. Bye-bye.